Okay, I'm sharing the link to the live stream for today. Okay, let me share it with Ravish as well. Okay, students, can you please check whether the live stream is going fine? Any of you? Okay, good. So, so we were actually learning about the pointers, right? And this is just a quick recap of what I had used to tell you yesterday. This is just the pointers and how we declare the pointer, how we assign the value to the pointer, how we will access the value of the value that is being pointed by the pointer, etc. Okay.
Sir, can you share the screen?
Oh, okay. Oh, just a second. I'll try. Right. Yes, I hope my screen is visible to you now, right? Is my screen visible to you, students?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, sure. Now,
Yes, sir.
Now, yeah. So we were looking at the pointers, and for the last two classes we were learning about pointers, correct? And we have actually learned about how to declare a pointer, how to assign the address of another variable to the pointer, the kind of pointers, what is null value to a pointer, and then we have also seen how we will dereference a pointer. That means how we will access the value that is being pointed by a pointer variable. Okay, and then we have learned pointer arithmetic also, right? So for that, let me also now show you the screen. Just a second. So I'm just showing you the code that we have written. So this was the pointer example 2, where we will assign a value to a data variable, and then we have a pointer variable, and we assign the pointer the data variable's address to the pointer variable, and then we use the pointer variable to access the address of the data variable, the value that is held by the data variable, and then we also print the value of the pointer variable itself, right? And from that we have actually understood yesterday that how the data will be how the data will be stored in the memory, and what it means by a pointer and what address will it store. Alright, so that is something that we know. And other than that, we had looked at few more examples. So this is another example 3, where we use the pointer arithmetic, right? So where we did the pointer arithmetic, where we had an array of elements and of type integer, and then we assigned the address of that array, the address of the first element of that array into a pointer variable, and then we use pointer arithmetic to go forward and go forward and access the elements in the array. Okay, so we have used both increment and decrement, but in this particular code we have commented out the decrement part. We had tried this increment part yesterday, and you must be remembering that during the increment I had a condition called if I not equal to 9, ptr plus plus, and for the decrement I had a condition like if I not equal to 0, ptr minus minus. Okay, so and then we had another this was the first program that we wrote for the pointers. Okay, so in this program we were learning what we were trying to understand what it means by pointers, etc., and we learned dereferencing and everything from here. Okay, now going to the so we learned pointer arithmetic. This is from tutorials point. Okay, this particular thing is from tutorial point, and we have already seen what are pointers, what are null pointers, right? Then we have also seen pointer arithmetic. Now let's take a look at array of pointers. Okay, so an array of pointer means that so an array of pointer means that you will have an array, okay, in which all the elements will be pointer elements, or okay, instead of just one single pointer variable, you will have an array of pointers. That's the idea. So let's take a look at this particular program over here. Okay, so in this particular program we have an array with 3 elements. Okay, and then we just print the value in the array. So we will print the index and then print the value. So in this one, right, we don't use anything called a pointer over here. There's nothing called a pointer here, and it will just print the value of var 0, 10, 100, then var 100, var 2, 200, right? So because the var is 10, 100 and 200, that's the array, and so that's the idea of arrays and how we will access the elements in the array. Now let's try and understand what it means by a array of pointers. Okay, so there may be a situation when we may want to maintain an array where we can store pointers to an integer or a character or any other data variable. Okay, so this is the idea. So if instead of actually just writing int star ptr, making just one pointer variable, here we have declared a pointer array, okay, or an array of pointers. Okay, an array of pointers. So it will, so if max is 10, right, if max is defined to be 10, then what is the max defined to be here? Okay, max is defined to be 3 here. Okay, so max is defined to be 3. So in this case it will create an array in which all the values will be pointers. Actually, I had the same problem like yesterday, where somebody started commenting on the video that is being live streamed. They just went and disabled the comments. Okay, so we have an array of pointers. This is how we will declare an array of pointers. So here max will be 3. So we will have int star ptr of 3. Okay, it declares ptr as an array of 3 integer pointers. Okay, or maximum integer pointers, where whatever is the value of max. Okay, so thus each element in ptr holds a pointer to an integer value. Okay, so let's take a look at this particular program. Okay, in this particular program we have max defined to be 3, and then we have the same kind of array, integer array, which we had seen in the previous example program. In this one we have again 10, 100 and 200 as the values in the array, and then we have an integer variable I, and then we have a pointer or an integer pointer variable of arrays. Okay, integer pointer of arrays with 3 pointer array, and then we will assign the address of each element into the particular pointer array. So var of i's address is stored in ptr of I. So which means var of 0's address is stored in ptr of 0, and then var of 1's address is stored in ptr of 1, and var of 2's address is stored in ptr of 1, ptr of 2, so on. Okay, and then we will print the values of the variable using the pointer. Okay, so that is like for I is equal to 0, I less than max, I plus plus, printf value of var percentage d is equal to percentage d, and then we use I is the iterator. Okay, and then we use the pointer dereferencing. So we have the pointer array ptr, which contains 3 elements. Now star ptr of 0 will dereference the element that is pointed by ptr of 0, correct? So that will be 10. Then star ptr of 1, 100. Then star ptr of 200. So that's the pointer dereferencing. That will print the same code. Do you guys understand this? Do you have any doubts regarding this? Do you want me to execute this and show it to you?
No, sir.
Right? No need. Yeah. So that's pretty simple, right? Which means that it is, see over here what you need to understand is that we have just assigned another array, okay, which is a pointer array, which means that an array which contains all pointer values, and in this particular example we assign the pointer array with the addresses. Okay, so we will assign the address of var of 0 to pointer of 0, address of var of 1 to pointer of 1, and so on, and then we use the pointer of I using the dereferencing to print the values in the array var. Okay, so that's a pretty simple example. Okay, it must be very easy for you to understand as well now, right? Because you have already done the pointer arithmetic, and you know what is an array, etc. Okay, now we can also use an array of pointers to character to store a list of strings as follows. Okay, now here we have a 2-dimensional array, correct? Here we have a 2-dimensional array which contains the strings Zara Ali, Hina Ali, Nuha Ali, and Zara Ali. Okay, now in this one the max is set to be 4, and so if we are going to print the values of the names, right, we will use %s string formatter, and in a for loop from I is equal to 0 to I less than max, that is I less than 4, which means 0, 1, 2 and 3, that is 4 values, 0 Zara Ali, Hina Ali, Nuha Ali and Zara Ali will be printed. So value of names of percentage D, that is names of 0, names of 1, names of 2, names of 3 will print Zara Ali, Hina Ali, Nuha Ali and Zara Ali, correct? So it will print it this way. So you can actually store the pointers for this one also if you want. So this one, you need to understand that this is actually a 2-dimensional array that you have defined, and look at the usage of star here. So let's just copy this code and put it in our Emacs. So pointers strings to the array. Let's see. Correct. So now let us take the terminal. So yeah, the terminal and GCC computer pointers underscore to read and -4 pointers So it is now going to print the values. Let's see whether it is going to print the values. Pointers underscore to the string array. Okay, so it is printing Zara Ali, Hina Ali, Nuha Ali and Sara Ali. And one thing that you need to understand here is, if I remove this star, right, if I remove this star, then it should probably result in a compilation error, right? And why is that, and how can I avoid that? I can do it this way probably, right? Let me just see. Okay, but here also I have defined it as a multi-dimensional array with must have bounds for all dimensions except the first. So it's I need not actually have a bound for the first one, but for the rest of the things I need to have a bound. So if I do it this way, then array mismatch plus 1 character. Okay, so what is the error that we are getting when we tried max and max plus 1? So when before that, when we had removed the star and we put two square brackets to denote that it is a multi-dimensional array, it gave us an error that declaration of names as multi-dimensional array must have bounds for all dimensions except the first dimension. Okay, so we tried to put the dimension for the second one, and the second one, it cannot be max, right? It cannot be max. So let me just put it as, say, 50. Yeah, it worked. Okay, you know why it was not working earlier? Say earlier when I had put max, right? What does it mean? It means that the array that will be finally created will be of the size names of 4 by, because there are 4 entries, 4 by 50. Okay, so when I put max, then it was actually doing 4 by 4, but the values, right, are definitely more than 4 characters long. So Sara Ali, Hina Ali, Nuha Ali and Sara Ali all are more than 4 characters long, right? So which means that it always resulted in an error. Now because of that, I remove the max and put it as 50, or else what I can do is I can count the number of characters 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so now this should compile. So if I put 8, then also it should compile is what I believe, and if I put 7, it should fail, right? It failed when I put 7, and the reason for that is I am trying to store a string which is more than 7 characters long into the array. Okay, and that resulted in an error. So 8. Okay, but then 1, 2, 3, 4, 5, 6, 7, 8. There are only 8 characters. Now this could actually result in an error, and I should actually have 9 characters here, because I should also be looking for the string terminating character \o, \0. Okay, so this way I will be able to run the code, and it will run the same way like how we had it earlier. So earlier what we had was, we had only this. So this is like a array of pointers, okay, which are pointing to certain one-dimensional arrays. Okay, so essentially you can understand that this is a two-dimensional array that we have created, and the way we are going to print the value is values of names of 0 is Zara, Sara, Ali. So that is printed by I, names of I, names of 0. So names of 0, you know that will anyway be referring to an address. You don't have to use ampersand there, because it is a array. Okay, so you have names of 0, names of 1, names of 2 and names of 3, printing all these 4 names. Is that clear? What I have done over here with the multidimensional arrays? Say, if I want, I can always fix the number of elements, and I can fix it this way. Okay, even if I fix it this way and compile the code, okay, the code is going to run. Okay, and if I fix it this way, even then it will work. Correct? And another way would be to use with pointers, and this is what we started with this. This is where we started with this example. Is it clear to all of you guys?
Yes, sir.
Okay, I hope there is no doubt regarding this. Okay, so that's an array of pointers again. That's for the string, by the way. And now let's go back to the previous page. So, and then we will look at what is a pointer to a pointer. Okay, so we know that we have already looked at a drawing example yesterday, where we had a pointer variable and then a data variable, and what value will be stored in the pointer variable's data part, correct? And what will be the address of the data variable, and that address will be stored here, and then the data variable will have some value assigned to it, etc. Right? So a variable in general is not a pointer variable. A pointer variable is a variable which is storing the address of another variable. Okay, so a variable contains a value. Pointer has an address which is pointing to a value or a variable. So we have one pointer which is pointing to one pointer, and that pointer which is pointing to a variable. So that is the pointer to a pointer. Okay, so we have a variable which is pointed by pointer A, and pointer A is pointed by pointer B. So if you use pointer B, then you can point to pointer A and variable together, correct? So a pointer to a pointer is a form of multiple indirection. Okay, so a pointer to a pointer is a form of multiple indirection, or you can think of it as a chain of pointers, right? So a pointer to a pointer is a form of multiple indirection, or it is a chain of pointers. Okay, so that is this figure that you see is a pointer to a pointer. Normally a pointer contains the address of a variable. When we define a pointer to a pointer, the first pointer contains the address of the second pointer, which points to the location that contains the actual value as shown below, right? So when we declare a pointer, that pointer will be storing the address of another variable, but a pointer to a pointer will have another pointer which is pointing to the first pointer's address. Okay, so a variable that is a pointer to a pointer must be declared like this. So you use 2 stars. So if you use a single star, it means that it is a pointer variable. If you use 2 stars, it means that it is a pointer to a pointer. Okay, so a variable that is a pointer to a pointer must be declared like int star var. Okay, like the int is the type, or in general it will be type space star variable name. Okay, so this is done by placing an additional asterisk in front of the name. For example, the following declaration declares a pointer to a pointer of type integer. So let's take a look at this particular example. So when a target value is indirectly pointed to by a pointer to a pointer, okay, I hope you are able to comprehend this particular English sentence that is written here. When a target value, that is what is held by the data variable, is indirectly pointed to by a pointer to a pointer, so which means that the variable is pointed to by one pointer, and then another variable, another pointer variable is pointing to the first pointer. So the second pointer is pointing to the first pointer, which is indirectly pointing to the variable. Okay, so when a target value is indirectly pointed to, okay, yes, okay. So when a target value is indirectly pointed to by a pointer to a pointer, accessing that value requires that the asterisk operator be applied twice. So we will apply the asterisk twice for a pointer to a pointer. Okay, so we have int var, that is a data variable. Then you have int star ptr, which is a single variable, which is a pointer variable. And then you have int star ppptr, right? So which is a pointer to a pointer. So you have a normal variable, you have a pointer, and then you have a pointer to a pointer. Now let us see how we will assign these, addresses, etc. So var is given the value 3000. So that is the wow, I just disabled the chats and I am getting chats again. Let me just report the okay, I guess it will be held for review, so I don't have to worry. Okay, so we have a variable which is assigned the value 3000, and then we take the address of variable and assign it to the pointer, right? We have the pointer here, which is defined as declared using star ptr. So that is a pointer which is pointing to a variable of the type integer. Okay, and then we assign the address of var to the pointer. Ptr is equal to ampersand var, and then we will assign the address of the ptr, okay, to the pointer to the pointer. So we will use address of ptr and save it in ppptr. Okay, so that's the pointer to the pointer. And when we are going to dereference the value, so when I say dereferencing, in this particular example, can someone tell me what is going to be printed in all these three different statements?
Sir.
3,000.
Yeah, it will print 3000, 3000, 3000. It will print 3000 in three different lines, because the first one is value of variable is 3000. Value available at star ptr is again 3000. Value available at pointer to pointer is again 3000, and this is dereferenced using double star. Okay, so when you are going to dereference a pointer, you will use star ptr, and when you are going to dereference a pointer to a pointer, you will use double star. Okay, so when the above code is compiled and executed, it produces this particular result. Is it clear? Do you want me to run this particular code, or let us just run this code? Let's just run this code. The reason why I'm running it is we know that we are making sure that the code is fine. Okay. So xpn okay. So I've saved it as pointers to pointer, or pointer to pointer, whatever it is. Now let us compile the code. Pointers to pointer. Let's see. It's pointer. Okay. We compiled the code, and yes, the code compiled without any error, and we can try running the code, and it will print 3000, 3000, 3000. Correct? So this is the example for a pointer to another pointer. Okay. Now we have two more things. One is passing pointers to a function in C, and another one is returning pointers from function in C. Okay, so the fourth one, passing pointers to functions in C. Now this is something that we have already seen. This is something that you already know, because you have already learned. Just a second, guys. Yeah, because you have already learned call by reference in functions, correct? And call by reference in functions uses pointers. Okay, so let us just take a look at the content that we have to look into with passing pointers to functions in C. Okay, so here we have a function called get seconds, which is returning nothing. Okay, so get seconds returns nothing. Okay, but it takes a parameter which is a call by reference parameter, okay, which is an unsigned long, okay, and that's a call by reference example for this particular function. And this line where I have highlighted void get seconds unsigned long star bar semicolon, that is called the, what is it called? Function declaration, correct? So that's the function. This part where I have highlighted is the function declaration, and then you have the main function, correct? In the main function you have a unsigned long variable called second, okay, and then what you do is you call the function get seconds with the address to the variable sec passed into the get seconds. So which means that it is a call by reference, and the actual parameter is the address of this particular variable, and the formal parameter is a pointer to an unsigned long. So we have an unsigned long second and get seconds ampersand second, okay, that is the call by reference to this particular function get seconds. And then we have printf number of seconds is a long integer, okay, a long integer printed with sec. But you need to understand that the get seconds, right, it does not return any particular value. So what happens? It is very simple, okay. It is simple in the sense that all it does is it will assign the value of seconds into the variable sec, because we are passing sec by reference to get seconds, okay. So par is the pointer, okay, that we will use to access sec, okay. So void get seconds has the formal parameter unsigned long star par, and then you have star par is equal to time of null, okay. So which means that it is going to use the time function. So we have a stdi we have an hash include time.h also here, okay, and this time function gets the current number of seconds in and returns it as a long integer, and it will store it into the variable sec, and so it will be printed here. Is that clear, students? So let's take an example of time call by reference or pointers. By reference, so pointers function called by reference, time c, okay. So I have saved this code. Now I'm going to the terminal here, ls pointer start c. So these are the pointer c files that we have created. So this is the file that we want to compile. So gcc, okay, we compile the code, and when we run it will print the seconds that have elapsed from a particular reference point in seconds, okay, correct. You can see that it is just increasing. So let's just take a look at what happens here. Hold on, just give me a moment. Right, so I'm just trying to show you the time.h. Okay, so we have the library time.h. Okay, so let me reload. Okay, so it will actually, that's the one that will give us the time in seconds. Okay, so you have the function called okay, this one is actually telling us how we will actually use the time.h to get the time to a structure that is already predefined in time.h. Okay, so and then the appropriate functions associated with it. So let me see. Okay, so I'm going to show you another page. Right, yeah, so just reloading with the add block plus. Okay, so what you can see over here is a Unix timestamp. Okay, and you can see that right now the time is 11:42:13 a.m. and the time in seconds, right, is given to be this much. So let's try to run the program, and we have given 16445599943. 43 what was that, right? So let me run it again. 49, yes. So what we are seeing here, I told you that this one is giving us the time in seconds since a reference point, and the reference point is January 1st 1970 UTC. Okay, and why is this important? Because that is important, and that is an assumption with which the particular computer's time is set. Okay, so that's why I wanted to show you the Unix timestamp epoch and what value are we actually printing here. Okay, so because you need to make some sense out of that, right? And when you are actually going to convert it, right, it will give you the details like year, month, day, and all those things clearly, and that is what we saw in the time.h example in tutorials point we saw earlier. Okay, so that's with regards to calling a function with pointers. Okay, so the function which can accept a pointer can also accept an array as shown in the following example. So if a function is able to accept a pointer, right, then it can also accept an array. So so far we have just looked at passing a single variable. Of course, you have already worked on the matrices, right? Matrices with functions was the question that I had asked you this time, right? So there you should work with pointers. So yeah, so let's take a look at another example. Okay, so as another example, we have another function called getAverage, which takes an array. Okay, and for that it's just a pointer. Okay, so it's just a reference again. That is what you need to understand. So you have an int star array and int size that is passed to the function, and this is a function declaration, and the function definition is given below the main function, correct? Below the main function definition. So the getAverage definition is as shown in the highlighted text. So you have double getAverage, int star array and int size. Okay, so the idea is that we want to calculate the average of the array or average of the n elements. Okay, or the so if this is n, then you want to calculate the average of the n elements. Int I is equal, I comma sum is equal to 0, double average for I is equal to 0, I less than size plus I, and sum plus is equal to array of I. So sum is equal to sum plus array of I. So we are just summing up all the elements in this for loop. Okay, and then we have average is equal to double. So this is type conversion, okay. So we have the type conversion here, double sum divided by size, and that is going to give us the average. And why did we use double here? Because the average is defined to be a double variable and the sum is an integer variable. So if you want to do a floating point division, you need to do it with double, otherwise it will become a integer division, okay, and you will lose the decimal part, okay. So in this particular main function we have a array called balance which has 5 elements, okay, and then we have a variable called average which is of double type, and so we call the function get average with balance comma 5. So balance is a single dimensional array with 5 elements, okay. So we call it by balance comma 5 and we pass the balance array, right, to the get average function as a reference. So it's again called by reference, okay, but here we are passing an array. So you can pass an array to a function using call by reference. So this is how done by average is equal to get average balance comma 5, and then we print the returned value which is average. So this average is equal to get average and the return value, right? So this will this function, right, calculates the get average function calculates the average in the second last line, like average is equal to double of sum divided by size, and then it has a statement called return average, correct, and this return, right, will be the value that will be evaluated. So get average balance of 5 will evaluate to a particular value, and that value will appear here as a return value, and that value will be assigned to the variable avg. Okay, so this is similar to what we have seen earlier, but only thing earlier it did not have a return, it was returning nothing, so that is why it has a void return type. And you can see that over here in the return statement in the function get seconds, it has not returned a particular value, it has just returned, and it means that it is returned void. And in this second example where we are passing an array with reference, okay, or when we are passing an array to a function with using pointers with call by reference, we have used a return for the function get average with double return type, okay. So it will return a double number, and double number in the sense it will return a floating point double number, and so that's the idea. Is it clear? I don't think I don't think I want to actually run this code, because it's pretty simple, right? You can run this code by yourself and you can take a look at what is happening, right? So the average value will be 214.4, which is the average of all these 5 values. Okay, now let us go back to the next topic. So far we have seen pointers, we have seen pointer arithmetic, array of pointers, pointer to pointer, passing an array or passing a variable to a function with call by reference or using pointers is what we have learned now. We have already learned that, but we have looked at arrays also at this point in time. Next is we can return a pointer from a function in C. So when we are returning, right, so far we have seen int get seconds or double get seconds, void get seconds, okay, int get average, or int get max, int get min, etc. So here for that function, right, I mean all these I mentioned get min, get max, all are functions, okay. And what I meant with int get max, int get min, int get seconds, etc. is that this int part is the return type. There you are returning a value. So far, let me show you. So we have been looking at functions so far, say int average, okay, int a comma int b, right? This is one way. Another one was int average. Okay, so in these both things we have passed. In the first one we have passed call by value. In the second one it was called by reference. So we have passed a address to the function. Now, can the function return an address, say like this? Okay, so that's the question. So can the function return a reference or an address okay, so that is what we call as returning the pointer by the function. Okay, so return pointer from the function. Okay. So this is like you have we have seen that we can pass variables to the functions by reference or by value. Now we want to return some variable or some array from a function using pointers by reference. So that's the idea. So we have seen in the last chapter how C programming allows to return an array from a function. Okay, let's take a look at this particular example. Okay, so here, right, we have used int star get random. So here it is going to return a reference, and here we have an array called R, okay, which is of integer type, which is a static integer array, okay, which means that over the number of executions of get random, the static array R will preserve the values. Okay, now in static array R of 10, then you have an integer I, then you will get a seed. This is a seed. Okay, so you will start a seed or you will start a random process with the s random with time null. Okay, and then what you will do is you will try to get random values to each of the R variables. Okay, R of 0, R of 1, R of 2, R of 3. So up till R of 9, you are going to assign it some random numbers. Okay, and then you are just printing the random numbers, and finally you are returning the R. So R is a function. Oh, I'm sorry. R is an array of type static integer. Okay, so R is returned, and R is returned by reference. So from the main function, right, you will get you can actually do it this way. So for example, if you have a pointer star p, okay, so it's a pointer to an integer star p int I, and then you have p is equal to get random. So we will call the function get random. So get random will return an array of random numbers, of an array of 10 random numbers, correct? So get random will return an array of 10 random numbers, and it is stored to p because p is a pointer, is an integer pointer. So since get random is returning an reference, you can just use get random, and it will, and whatever the value that it is returning will be assigned to p. And then what you're going to do is you're going to dereference this particular pointer using pointer arithmetic. Now that is one thing that you need to understand here. So here you have used for I is equal to 0, I less than 10, I plus plus, printf star p plus I is equal to whatever the value, and that is printed by, so p plus 1 or p plus 0, p plus 1, p plus 2, p plus 3, p plus 4 up till p plus 9, and then we will print the random values, correct, and that is printed using star of p plus I. So p plus I is a pointer arithmetic and dereferencing the result of p plus I, correct. So when you run the code, right, it will generate the random numbers in the get random, and it will print it, and before returning the R, and once the R is printed, the main function will start printing the random numbers. Is that clear, students?
Yes, sir.
Okay, so let us just run this particular
Yes.
code. Let's just copy the whole code and let's put it in our editor Emacs. Okay, so this is pointers function pointer. So this is clear. Okay, over here in function, it's just a warning. Okay, it has compiled the code. The code has compiled. It's just a warning because let's try to run the code. Pointers function pointer, and it has actually made some random numbers and it has printed it. Let's run this program again. You can see that the random numbers have changed now, right? That is why you call it as a random number, and it is actually doing this random number generation properly because we have a srand with time null, so which means that the random number is actually seeded. So this is called setting a seed. Okay, so this is something called random number generation, and a pure random number generation is not really possible with a computer. So in this one, right, the random number generator was seeded with the time null, which means the time right now whatever is the time in seconds, correct. If I put another seed, let's say I'm going to cut this, okay, and I'm going to put it here. Let's say I will put the seed as 100, some value 100. Okay. Now when I'm going to compile the code and when I'm going to run the code, it will generate a set of random numbers, and when I run the code again, you can see that the random numbers it has generated, right, again are the same, right. So can you say that this is a random number, because every time I'm running the code it is generating the same random numbers. So can you say that it is random numbers? No, it is not really random numbers that is being generated when I set the seed to be a single constant number. Okay. So instead of that, I can put the time now, but that is also something that is totally dependent on the time value. Okay. So now when I compile it, it will start generating random numbers. Correct. All right. So that is with regards to return pointer from functions in C. So what all did we learn with pointers? With pointers we have learned the how to declare a variable, pointer variable, what are the types of the pointer variables. Then we have seen dereferencing. Then we have seen multiple other things like null pointer and pointer arithmetic, array of pointers, pointer to pointer, and passing pointers to functions in C and return pointers from functions in C. So this is what we have covered with regards to pointers. That's it, guys. If you have any questions, you can ask me that now, or else I will leave.
No doubt.
No doubt. Okay. So that's it, guys. Thank you so much. Nobody else has any doubts?
No, sir.
No, sir.
No, sir.
That's pretty good.
No,
So
sir.
I'll stop streaming and I will stop recording. Okay. So I'll stop. So I'm going to stop presenting now to you. Stop streaming and recording.